Hello everyone, welcome to all of you in video lecture. I'm going to start model number 5. So name of model is equipment and techniques for setting up of power generation structures. So in this uh, module, so these are the contents: hydropower station, thermal power station, solar power station, atomic power generation and windmills. But in these lectures we have to focus on hydropower station. Now hydropower plant. So I am dividing this hydropower plant in part 1 and part 2. Part 1 I am going to explain some of the components, and part 2 I will explain some of the components. Hydropower plant is nothing but it is dam is constructed across the river, and the main source of hydroelectric power plant is water, right? So during the rainfall we have to collect the water in the dam, and dam is one of the main source or main component of the power plant where we can generate the electricity. So first, what is principle of hydropower plant? The main objective of hydropower plant is, or hydropower scheme is, to convert the potential energy into electrical energy, right? So how to convert? So we need some height of water or mass of water, and that water should be flowing in the stream with a certain fall to the turbine, right? Means we have to fall water from a high level to low level. On the turbine you have to fall that water. So during this process the potential energy is converted into electrical energy. So that is the main principle of hydropower plant. Now the output of this power plant is depends upon the flow and head. So flow means how much water is discharging from the penstock or from the pipe, and how much head of water is available, right? So this is the output, right? Or the flow and head, on that the output is depend. Now see a simple overview of hydropower plant. So first, that is water intake, second trash rack, third dam, water flow, penstock, turbine, generator, transformer, electricity, right? And at the bottom below the turbine you can see water discharge, that is tail race, right? So water intake, right, means the reservoir. First is the reservoir where we can collect the water, and dam is constructed across the river where we can store large quantity of water, right? So after that, dam intake, that is water intake. So water intake means we have to collect the water, right? And the intake we have to join one of the pipe or penstock. From that penstock we can discharge, or we can pass the water level or water from high level to low level. So at the high level means at the intake we have to connect the pipe, and at the bottom we have to attach, or we have to install the turbine, right? So that potential energy converted into kinetic energy, right? So this is first part. So turbine is nothing but it is one type of equipment where the rotation starts. The turbine may be Pelton, maybe Francis, maybe Kaplan, right? So again this Pelton turbine, Kaplan turbine or Francis turbine depends upon the how much rotations is required or how much energy is required. So you can provide the Pelton turbine, also you can provide the Kaplan or Francis turbine also, right? So at the turbine one of the vertical shaft is attached to the turbine, right? When turbine rotates, the hydraulic shaft is also rotate, then the generator starts, or we can say the energy generating the energy, right? And generated energy you can store in the transformer, right? So from the transformer you can supply the line or electricity through the power line to the city, right? So this is the main overview of the hydropower plant, right? So at the top you can see head gate. So head gate is provided to control the flow of water. Trash rack is provided at the water intake to control the debris and to control the damages of mechanical equipment parts. And at the bottom you can see water discharge, where means after the turbine rotates, then you can pass out that water, that is water discharge, through the tail race, right? So what is use of that water discharge? Either you can discharge that water, or you can supply the water in the river, or you can again recycle it. You can this water you can use for the hydro power generations, right? Means same water you can supply through the pipelines again in the reservoir or in the dam, and again you can use that water for the power generations, right? So this is the principle or working principle of the hydropower plant. So block diagram also you can see. So reservoir first, that is dam. So reservoir means where we can collect the water. Dam constructed across the river. So from the dam, then intake where we can collect the water. Then penstock. Penstock is nothing but it is one type of pipe. That pipe may be concrete pipe or steel pipe. Through the pipe we can supply the water to the turbine from high level to low level. From high level to low level. So turbine, when the turbine rotates, then the electricity generated, and that generated electricity we can store in the transformer, and through the transformer you can supply the electricity to the city. So this is block diagram. So from block diagram you can see the components or parts of the hydropower. So elements of hydropower plant, these are the elements of the, or these are the components of the hydropower plant. First, dam, intake, penstock, turbine, generator, transformer, outflow and tail race, and last one that is the powerhouse, right? But in this part 1 I am going to explain only 3 components, that is dam, intake and penstock. So next part or part 2 I will explain turbine, generator, transformer, outflow and powerhouse, right? So dam is the first component we can say. So dam is constructed across the river to store the water, so that water we can use for drinking also, drinking purpose also, agricultural purpose also, industrial purpose also, and hydropower generation or to generate the electricity, right? So if it is multi-purpose or single purpose means only one purpose, either it is drinking or industrial purpose or agricultural purpose or hydropower generations, right? And multi-purpose means you can use for various purposes, right? So dam is one of the structures where we can store the water and we can generate the electricity. So this is the theoretical parts. The movement of water can be used to make electricity. Energy from water is created by the force of water, right? So by gravitational force you have to supply the water from high level to low level. So at the bottom one of the turbine, when water reaches at the end of the pipe, it hits, then it after hits, then it starts the rotations, and the turbines rotates the connected shaft, and then the electricity generated. Now second part is the intake, where we can collect the water, how much water is required, right? That much quantity of water we can collect in the intake, and through the intake we can supply the water, or we can connect the pipes to the intake, right? So intake is nothing but it is a water intake must be able to divert the required amount of water, means how much water is required that you can divert through the power canals or through the penstock, right? So without producing a negative impact on the local environment, means how much water is required, that water you can use only for the hydropower generation. The remaining water you can use for other purposes. That is the main purpose of intake, right? Then penstock is nothing but it is a pipe, right? To one end of the pipe is connected to the intake, and another end of the pipe is connected to the turbine, all right? So turbine means just you have to throw or you have to hit the water through the penstock, right? You can see the pipelines. That pipelines may be concrete, maybe steel, right? So penstock, conveying water from intake to the powerhouse, right? So powerhouse is at the bottom, intake that is at the top, so that conveying water from intake to the powerhouse. Of concrete in low head means if it is low head or small, very less quantity is available, then you can use concrete pipe. And if it is large quantity of head is available, large quantity of water is available, then you can use the steel pipe. So penstock has some arrangement in the penstock. One is automatic butterfly wall, air wall, and surge tank. Right. If the shut off the water flow, if penstock ruptures, right. So if it is suddenly, if you stop the supplying water, then there are chances of bursting the pipes or rupture the pipes, right? So if we then the automatic butter wall is provided in the penstock, so that we can avoid the damages or we can avoid the bursting the pipes. Air wall also provided. Sometimes the pressures or some air also present in the penstock that we can remove. So internal pressure as is equal to atmospheric pressure you can maintain. Surge tank, so it is one type of tank is provided in the penstock, right? So what is use of that surge tank? Reducing water hammering, means if you suddenly stop, then there are chances of backwater. Because of that backwater, there are chances of water hammering in the pipes, right? And because of that, there are chances of damages to the pipes, right? So by using this surge tank, or we construct or we provide the surge tank in the penstock or outside the penstock or near the turbines, right? So we can we can remove prevent the damages to the pipes, and we can regulate the water flow, means how much pressure is required, how much discharge is required, that also we can regulate, right? And important is we can maintain the pressure inside the penstock also, right? So penstock is very important, or very main component we can consider. Through the penstock we have to supply the water from high level to low level, and when we supply the water from high level to low level through the gravitational, there is a lot of pressure, right? That pressures you have to maintain, that water hammering you have to maintain, then you have to maintain the air pressure also, and you have to maintain the ruptures also, right? So these arrangements are given in the penstock. Trash rack is you have to provide, or you have to maintain at the water intake, so we can remove the debris from the water, or at the for the cleaning of machines also trash rack is required. And in order to save waterways and electromechanic equipment from any damages, if you want to maintain, or you have to give the proper ways, then we have to provide the trash rack. So set up steel bars on the edge to the flow of water and space about 1 inch apart, right? So one of the jali, or one of the way that you have to provide, or steel bars you have to provide. So distance between two steel bars are 1 inch you have to provide. So this, right? So trash rack is you can see at the water intake you have to provide the trash rack, so that we can remove the debris, or we can control or the damages of any mechanical part.